recording already?
I mean, now.
Are we good? We're slated? Here we go. All right, first one. Notice that I want the three trigonomic ratios. I want the sine of k, and remember k represented an angle. I want the cosine of k, and I want the tangent of angle k. But we're missing some information. But the good news is it's a right triangle. When it's a right triangle, what can we use in order to find the third side? Raise your hand if you know it. All the hands are up, I swear. U, what did we use? Uh-oh.
Pythagorean.
Pythagorean theorem, very good. Everybody, find the Pythagorean, use the Pythagorean theorem to find our third side here. While they're working on that, you tell me how to set it up.
The Pythagorean theorem?
Yeah.
A squared plus b squared equals c squared.
Okay, so we're going to be using this formula. But what sides am I given, Noah? I mean you. What do I do?
You're given A and C, but you're given B.
Okay, so fill up the actual sides. I'll put it up.
12 squared plus b squared equals...
Nice. Notice they gave us the hypotenuse this time. So we have to solve for a leg. Keep working, I'll take care of something.
Good shape.
We all make mistakes. All right, so I need you to help me walk me through this. What is 12 squared? Don't look behind you.
144.
Yes. And you, what is 20 squared?
400.
Thank you, whisperers. So we get the b squared isolated by subtracting 144. When I do that, what am I left with? You. You're burning up our camera. We got so much film.
256.
256. To solve a square, you square root it. So b is what? U. Say again? 16. How many people got 16? All the hands are up. So now it should work very quickly. Boom, boom, boom. We should get our ratios. So you. What are my three ratios? Pop them out.
So for total,
Yep.
sine is opposite over hypotenuse.
Which is?
Hold on. 16 over 20.
Cosine,
Adjacent over hypotenuse.
which is?
12 over 20.
Tangent.
16 over 12.
Now, I know that you know this and I know this. All of those will be wrong in a test. Why?
Simplify.
Simplify. So you. What would my three simplified ratios be?
3/4.
The first one's 3/4. Debatable.
4/5.
Hey, there we go.
3/5.
Hello.
And 4/3.
Done. So that's how we find the three trigonomic ratios from an angle if we're missing a side. Next. Now, step one, when they give you an angle. This is my good side? Okay. So, I need to identify what two sides I've been given information about. So put your eyeball behind the angle, and from this vantage point, what two sides do we have information about? You.
The opposite
I got the opposite
and the adjacent.
and the adjacent. Okay. So I think of our wonderful tribe, SOHCAHTOA. Which trigonomic ratio involves opposite and adjacent U? Tangent. So that's the one we use to set it up. What would my equation be then?
It would be 5 over x.
Okay, well, tangent of, what's my angle measurement here?
35.
Equals, and then you gave me the ratio of?
5 over x.
Everybody okay? Now, you solve for the variable any way you need to. But right now it's in the denominator. So U, what do I do?
Multiply by x.
Get it out of the denominator. And now I have x times tan of 35 equals 5. From here, U. What do I do? I want to get x all alone.
You divide by tan of 35.
That's what I'm talking about. Everybody get your calculator out and get it. Take 5 divided by tan 35. I want it to the nearest hundredth squiggles because we're approximating. 5 more seconds. 4 more seconds. 3, 2, knowledge bomb. Yes, you. What are we left with? Bless you. Sorry, everyone was sneezing and being rude. Go ahead.
7.14.
7.14. How do people agree? And that is how you find the 3 trigonomic ratios of a triangle from one angle's vantage point, missing one side, and how you would solve for a missing side given an angle at a right triangle.